Hi, this is an example problem from Chapter 8 that involves how to relate angular variables with tangential variables. Pause for a moment and read the question. So as you can see, there's a bird's eye view of a helicopter, and at the instant shown, the helicopter is given an angular speed, 6.5 revolutions per second, and an angular acceleration, alpha equals 1.3 revolutions per second squared. So we've been given the angular quantities, omega and alpha, and it's important to note that the angular quantities are the same at any point along the propeller, because each point on the propeller is going to turn the same angle in the same amount of time, right? However, the tangential variables, because of the radius, they're going to have different values. The further out you get from the center of rotation here, the greater the value will be for the tangential variables. And we have a simple set of equations that relates the angular variables here over on the right with the tangential variables on the left. How do we convert from one to the other? You just take the angular variable in radians, it must be, and multiply by the radius. So it's important that we got to be in radians, so the first thing we got to do in this problem is convert our angular quantities to radians. So let's start with the angular velocity, 6.5 revolutions per second. Convert that to radians. We know that for each 1 revolution, that's 2 pi radians. And we can cancel out our revs. And when we calculate this, it comes out to 40.8 radians per second. And similarly for the angular acceleration, 1.3 revolutions per second squared. We're going to convert that to radians. 1 rev, 2 pi rad. Convert that to radians, and the answer is going to come out to 8.17 radians per second squared. So now we're ready to go ahead and convert these angular quantities, which are the same for points 1 and 2, to the tangential quantities. Let's start with point 1. Point 1 is closer to the center of the circle, therefore it's going to have a smaller value of the tangential quantities. So to get the tangential speed vt, we're going to multiply the radius times the analogous angular quantity, the angular speed omega. The radius in this case is 3 meters at point 1, and omega is equal to 40.8 radians per second. When we go ahead and calculate that, we end up with a value 123 meters per second. And again, notice that since I have multiplied by meters, the radians can be dropped. And just to remember that this is 0.1, let me go ahead and write that as 1 here. Now for the tangential acceleration at point 1, same process, radius times the angular acceleration. What's the radius at point 1? It's 3 meters. What's the angular acceleration? 8.17 rads per second squared. And we're going to get an answer here which comes out to 24.5 meters per second squared. So there is our value for point 1. Now to do point 2, just exactly the same thing. Now we just got to do the radius at point 2. I guess I should call this R1 here. And notice that it's only the radius that changes. Still the same omega, still the same alpha. And so now we're looking at 6.7 meters. And we're going to multiply by the same alpha below alpha. Here, omega, 40.8 rads per second, 8.17 rads per second squared. And we're going to go ahead and ignore the radius now because we just multiplied by, ignore the radians, we just multiplied by the radius. And so when we do this calculation, we come up as the speed 274 meters per second, your tangential speed, whereas the tangential acceleration, 54.7 meters per second squared. And so we have our answers here for part B. Now, it's important to point out that these are further from the center. They have a larger radius, in other words, right? So they are larger values. Larger values for the tangential quantities.